Okay, so in this video, we will solve the Atwood's machine problem. The Atwood's machine is a simple machine. It's got two blocks of masses M1 and M2 connected by a string that passes over a smooth pulley. Okay, there's one string that passes over the pulley is massless and frictionless that we already said, it was going to be the case until we hit rotational dynamics. Okay, so our goal in this problem is to calculate the acceleration of the two blocks and also the tension in the string. It's just one string that we'll calculate the tension for. Okay, and what we'll do is we'll assume that M1 is greater than M2. Okay, so at this point, pause the video. Okay, and go ahead, draw the free body diagrams and set up an equation and solve the problem. See if your answer matches. Okay, so pause. All right, I'm assuming that you paused and you're going to check your work now. Okay, so I'm going to draw my free body diagrams. So first for M1, I have M1G pointing down. I have the tension pointing up, and this is not part of my diagram. For M2, I have M2G, make it slightly shorter, M2G pointing down, T pointing up, or two T's are almost the same dimensions. Okay, sorry, same height. Yeah. And at this point, this is our free body diagram. Now you could draw separate diagrams with the dotted arrows. I'm just going to add it to this picture just to kind of save space, and that way all the work could be just in one area. So for M1, since M1 is going down, we're going to have a dotted arrow pointing down, and we will write sorry, not M2. We will write M1G next to this one. And then for the other one, we're going to have an arrow pointing up, and I'll put M2G. Remember, okay, the whole point of drawing these arrows, the dotted arrows, is to realize that everything that's all the forces that are acting on the block itself, okay, the sum of all those forces will be equal to the dotted arrow. So for the first block, it'll be M1G and T combined will give you sorry, M1A. Oh, sorry, I made a mistake. This should have been A, and this should also have been A. I apologize for that. Okay, and then similarly for the second block, T and M2G combined should give you M2A. So let's go ahead and write our equations. For block 1, okay, we see that since the block is going down, M1G is the winner, T is the loser. So we can write M1G minus T is equal to M1A. Okay, now for the second block, we see that T is the winner, M2G is the loser, and the result would be M2A. So T minus M2G would be equal to M2A. Okay, now again, the advantage of writing these equations one below the other is that right away you see that there's a negative t in the first one and there's a positive t in the second one. So when we add these two equations, okay, we end up with M1G minus M2G is equal to M1A plus M2A. Okay, and we can factor out the G from the left hand side, which gives us M1 minus M2G, and on the right hand side we can factor out an A and have the expression look like this. And now we're ready to find A. A is simply M1 minus M2 times G divided by M1 plus M2. Okay, so this is our acceleration. Now we want to find the tension, and in order to find the tension we could use either of the equations. We could either use equation 1 or 2. Choose whichever one you want. I'm just going to choose 2. Equation 2 says that T is M2A plus M2G, and here we can replace A with M2 times M1 minus M2G over M1 plus M2 plus M2G. Now we can do a little bit of algebra. The common denominator would be M1 plus M2, and in order to make this both of them have the same denominator, we'd have to multiply and divide the second term with M1 plus M2. So what we end up with Okay, so I'm also going to distribute the M2 and M1 inside and on both sides and rewrite this as M2 times M1G minus M2 square G plus M2 or rather plus M2 M1G and then plus M2 square G all over M1 plus M2. Okay, and you see that this M2 square terms go out and we have two of the M1 M2 terms, so we can write this as 2 M1 M2G all over M1 plus M2, and this is our tension. Again, realize that both the answers are only in terms of things that are given, which are basically the masses, and we can use the acceleration due to gravity in these answers. Okay, so I hope you understood this problem, and if you did, then go ahead and take care of these two problems. Okay, one is pulley. We have a mass, say, let's call this guy M3, and let's call this guy M2, and let's put an M1 here, and let's say you have a string 1, a string 2. Okay, so our goal is to find A, okay, and then T1 and T2. So go ahead, solve this, check the answers with each other and see what you get. And let's try this guy also, which is going to be M1, M2, M3. Okay, three masses, two pulleys, everything is frictionless still. And then let's assume that that M1 is greater than M3, so M1 is going to go down, M3 is going to go up. Also, in the upper problem, assume that M1 plus M2, okay, is greater than M3, and then solve based on that. So basically, we're going to assume that M1 and M2 are going to go down, and M3 is going to go up. Just make sure to account all the forces, especially the on the block M2. Do not forget about tension 1 acting on M2. Okay, so do all this, figure out your answers, check with each other, and that's it for this video.